Hello everyone, welcome back to the channel uLearn Education Online.
In the previous videos, we have seen the application of op-amp. So one of the application of op-amp is differentiator. Okay, so what is ideal differentiator and how the circuit will be, and what are the disadvantages of using ideal differentiator, and how to overcome the disadvantages using practical differentiator, and how the frequency response curve of differentiator looks like. So these are the concepts I have covered in the previous video. Now we are going to see how to design the practical differentiator. Okay, so this is the differentiator circuit that is used. So for this differentiator circuit we have to design certain values. So the designing of any differentiator or any application is nothing but for this circuit the passive elements has to be designed compared with the input signal. Okay, so here the passive elements of the circuit is the resistors R1, RF, R compensation, and the capacitors C1 and CF for the given input signal parameters. Okay, now we are going to see what are the steps that are to be followed in order to design these resistor values and capacitor values for the given input signal parameters. The necessary steps that are followed is, for the first step we have to consider the cutoff frequency FA as the maximum frequency of a input signal. Okay, so in the second step we have to assume the capacitance value C1 that is always in the range which is less than 1 microfarad. Here we can assume the C1 value as 0.1 microfarad or 0.001 microfarad or 1 microfarad. I am stressing these three values. Why? Because in the practical experiments, we are assuming that the capacitor value C1 as 0.1 microfarad or 0.001 microfarad. So C1 is assumed. In the circuit, we have to find out the values of resistor R1, RF, R compensation, and thereafter the capacitor CF. Okay. So in the theoretical, we are assuming that the FB frequency is always greater than FA. Here, the FA is nothing but the cutoff frequency, and FB is the frequency at which the gain of a differentiator circuit start decreasing. Okay, so for this we are assuming that FB as 10 times of FA. We know the value of FB is 1 by 2 pi R1 C1 and FA as 1 by 2 pi RF C1. So 2 pi gets cancelled and C1 gets cancelled. Finally the RF value is equal to 10 times of R1. So from this we are obtaining the value of RF. Now you may ask how to obtain the value of R1. So here this R1 value we can find with the help of a FA cutoff frequency. So we know the FA value as 1 by 2 pi RF C1. Okay, so we are assuming the C1 value as 1 microfarad and RF. Okay, so final step we are finding that is RF C1 CF is equal to R1 C1. So we know the values of RF R1 C1. From this we can obtain the value of CF, and at last the R compensation value is R1 parallel to RF. So from this, if you follow these steps, we can easily design the differentiator circuit for the given input signal frequency. Now let us see one example model of designing a practical differentiator circuit with the given input signal frequency. Okay, so they have asked design a practical differentiator which differentiates the input sinusoidal with the maximum frequency of 200 Hz. So for this problem we have to draw what is the practical differentiator circuit. Here they have given the input maximum frequency signal as 200 Hz. So in order to design the practical differentiator, the first step we have to follow is we have to choose the cutoff frequency FA which is equal to the maximum signal frequency F max. Okay, so here the FA is 200 Hz. So here the FA value we are assuming it is 200 Hz, and we are assuming that the capacitor value C1 as 1 microfarad. So the what is the third condition? We know that the third condition is FB is equal to 10 times of FA. We know the value of FA as 200 Hz. Simply substitute here. We are obtaining the FB as 2 kilohertz. Okay. Now the fourth step is We know the relation, that is Rf is equal to 10 times of R1. Here we have to find out what is the value of R1. We know that the FB value is 1 by 2 pi R1 C1. Here we are assuming that the C1 as 1 microfarad. Now consider the R1 value as 1 by 2 pi FB C1. We know the FB value as 2 kHz and C1 as 1 microfarad. Simply substitute here. We are obtaining this R1 value as 79.57 ohms. After finding the value of R1, simply substitute in this equation in order to get the value of Rf. So Rf is, finally you are obtaining 795.77 ohms. Okay, so for this circuit we came to know the values, that is R1 is 79.57 ohms, C1 we are assuming it as 1 microfarad, and Rf is 795.77 ohms. Now the unknown values are Cf and R compensation. So in order to find out the Cf, the fourth step we are assuming is Rf Cf is equal to R1 C1. From this we can find the value of Cf as 99.9 nanofarad. So CF is also find out. At last the R compensation value is R1 parallel to RF. So here R1 is 79.57 and RF is 795.77. Just simply calculate the parallel equivalent resistance of R1 and RF, which is R1 RF by R1 plus RF. If you substitute those values, finally we are obtaining it is 72.33 ohms. So by following those 5 steps, we can design this practical differentiator circuit very easily. Thank you.